Welcome back. Here's another episode of Mr. Myron's mini math video lessons, or whatever it's called. But here we go, finding the greatest common factor. Again, we've talked about factors. We talked about common factors. I briefly spoke upon the greatest common factor. Okay, so let's focus on how we find that. We already talked about what it means. It's got to be a common factor between two numbers, right? It's the same, and it's the greatest value. All right, so there's two methods of doing this. Well, there's more than two methods, but there's really two methods that most people will think of. And the one is we could create a factor rainbow for 20. We could create a factor rainbow for 24, list all the factors, and find the one that's the greatest. And that works, and yes, it does work. And if the numbers are small, go ahead and do it. But when the numbers get bigger and bigger and bigger, there's a greater chance that you miss one of those numbers, which ends up being the factor that is the greatest, and it throws you off. So although it does work, it's very time consuming, and there's a greater chance of risk of getting it wrong than if you use the prime factorization to find this. All right, so let's do this. It says find the greatest common factor of 20 and 24. All right, so this is going to be a little bit different. It's a lot like the prime factorization. It's the same skill set, 20 and 24. You're going to write those down. We're going to do a large upside down division. Okay, it's the same skill set, except instead of just doing it for one number, we're doing it for two numbers at the same time because we're looking for common, right? The greatest common factor. So we want all the common numbers that come out. All right, so we're going to sit there again. We're going to take out the prime numbers. All right, we're going to take out the prime numbers. So here we go. Let's take out the prime numbers. Again, we're going to start with the smallest one. So we'll start with 2, right? Does 2 fit into both 20 and 24? It does. What is 20 divided by 2? 10. What is 24 divided by 2? 12. Upside down division again. Here we go. They're both even. We can pull out another 2. 10 divided by 2 is 5. 12 divided by 2 is 6. Okay, so here we're done. All right, I know in the prime factorization we got all the way down to 1. We're not doing the prime factorization just yet. We're doing the same skill set as the prime factorization. We're done because we have neighbors. The numbers right here are right next to each other. You are done. You cannot break these down anymore. There's nothing more that they can share because the numbers will jump right over each other. Right, so since they're there, one's even, one's odd, 2's not going to work, and they're going to jump right over. So there's no other factors or prime numbers that fit into both 5 and 6. That's called neighbors, so we're done there. All right, so what is the greatest common factor? How did this help us find the greatest common factor? Let me undo that. The greatest common factor is over here. It's not 2, it's not 22. It's we multiply these numbers, all the numbers on the left side that they have in common. We have to multiply those together. What's 2 times 2? 4 is your greatest common factor. Now you might say, Mr. Myron, all that work, all that division, all that multiplication, all that understanding, oh, when do I end? How to know to end? I think it would have been easy if I just did a factor rainbow. And like I said, with the factor rainbow, for both of those numbers, it might be quicker for some numbers. These are smaller numbers. We're going to be getting to bigger and bigger and bigger numbers where it's not as efficient. Can you do it that way? 100%. But I'm just trying to show you there's another faster and more efficient way. But whatever's comfortable with you. If you don't like this method, you like this method, that's fine. But today, stay with me, write with me, do these problems with me. We will get through them. We'll practice these. We're going to do these a lot, especially if you're in class, like during that wind period. We're going to be doing these a lot. Try your best to stay with me and do these because this eventually will be your preferred method. I have no doubt about that. So the greatest common factor is 4. All right, so now we're up to 40 and 72. Who here, raise your hand, wants to do a factor rainbow for the number 72? 1 times 72. 2 times 36. 3, I don't even want to think about it. Right, so the factor rainbows, I'm telling you, it works when numbers are small. Go for it. I personally do not want to make a factor rainbow for number 72. So what I'm going to do is I'm going to set up my upside down division for both of them. Luckily, they're both even, so I know I can pull out a 2 for both. 40 divided by 2 is 20. 72 divided by 2 is 36. They're both even again. Pull out of 2. What's 20 divided by 2? 10. What's 36 divided by 2? 18. They're both even again. Pull another 2. 10 divided by 2 is 5. 18 divided by 2 is 9. Okay? Can I be done here? Can I be done here? Am I done here? We have a prime number. We have a prime number. Okay? 5 and 9. If we have a prime number and this prime number does not fit into this number, there's no way that they can have something in common. Because the only number that fits into 5 is 1 and 5. Does 1 or 5, is 1 a prime number? No. Is 5 a prime number? Yes. But does 5 fit into 9? No. So I know that I'm done. Is the greatest common factor of 40 and 72 222? That doesn't even make sense. Right? Is it just 2? That doesn't make sense. We have to multiply all the numbers that we pulled out, all the prime numbers that we pulled out. 2 times 2 times 2 is 8. 8 is our greatest common factor. See how that's a lot faster than if you were to do a factoring over 40 and a factoring over 72? 100%. The big thing is you have to be good at your division. But again, we're just dividing by 2 here. It's not like we're dividing crazy numbers. Right? We're just cutting something in half. We're cutting 72 in half. If you have to use a calculator to do that, do it. All right? So it's really not that big a deal. It's not crazy division. The biggest thing is understanding the steps, understanding the process, where the numbers go. Okay, let's try it again. If you think you want to try this one on your own, go for it. Pause me. Come back after you're done. Check it out. If you want to try it on your own, go for it. All right, 64, 48. And I got to stop being so nice with these numbers. They're all even numbers, so I got to start working out some odd numbers in here. They're both even. Let's pull out a 2. 64 divided by 2 is 32. And you might not do that as quick as me. And that's okay. That's okay. As long as you can get there, that's fine. All right? 48 divided by 2 is 24. They're both even still. Pull out another 2. 32 divided by 2 is 16. 24 divided by 2 is 12. They're both even still. Pull out another 2. 16 divided by 2 is 8. 12 divided by 2 is 6. They're both even. Pull out another 2. 4, 3. We have neighbors, right? 3 and 4 are right next to each other. We have neighbors. We are done. We can't do anymore. We now need to multiply all these numbers together. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. 16. All right, so the big reason why I wanted you to do the prime factorization using upside down division is you're going to use that for the greatest common factor. You're also going to use that for your least common multiple. All right, so it's not the same exact thing because you don't always end with 1, but it's the same concept. You're always pulling out a prime number. You have to pull out prime numbers here. All right, you have to pull out prime numbers in order to make this work. All right, that's it. Good luck. Reach out if you need help with this. We're going to be practicing this quite a bit, the greatest common factor, using the upside down division. It's very helpful. It's the most efficient way that I can help you get that answer. Good luck.